ASTM D4318 contains test methods to determine the plastic limit and liquid limit of a soil, as well as its plasticity index. Consistency is used to describe the ability of the soil to resist rupture and deformation. It is commonly expressed qualitatively as very soft, soft, stiff, very stiff, and hard. The Atterberg limits are measures of critical water content of a fine-grained soil, at which soil changes from one state to another. For example, when the water content of a soil in a solid state exceeds the shrinkage limit, it transitions from a solid state to a semi-solid state. The soil is very stiff at solid state and becomes softer as it changes from one state to another towards the liquid state. The equipments used are as follows. Number 40 sieve with pan. Moisture cans. Glass plate. Porcelain dish and spatula. Mortar and pestle. Liquid limit device. And grooving tool. Weighing balance and drying oven. Shown below is the soil background of our specimen. Procedures for the liquid limit test. Weigh each moisture can. Take the soil sample and pulverize it using the mortar and pestle. Take the pulverized soil and let it pass through a number 40 sieve. Put the soil that passed through the sieve in the porcelain dish. Add small amounts of distilled water on the soil and thoroughly mix. Continue mixing and adding water until it appears as a smooth, uniform paste. Take the soil paste and put it in the cup of the liquid limit apparatus at the point where the cup rests on the base. Spread the soil into the cup to a depth of about 10 mm at its deepest point. The soil patch should form an approximately horizontal surface. Use the grooving tool to carefully cut a clean straight groove down the center of the cup. The tool should remain perpendicular to the surface of the cup as the groove is being made. Turn the crank of the apparatus at a rate of approximately 2 drops per second and count the number of drops it takes to make the two halves of the soil pad come into contact at the bottom of the groove along a distance of 13 millimeters, which is about the length of the groove handle. Put the soil sample from the cup to a moisture can. Weigh the moisture can with the soil sample and put it in the drying oven and leave it for a whole day. Procedures for the plastic limit test. Get an amount of the soil paste and mold it into a ball. Roll the ball between the palm and the glass plate with sufficient force, forming an ellipsoidal mass until it becomes a thread with a diameter of 3.2 millimeters. Reform the soil thread into a ball and repeat until the soil breaks or crumbles when rolling. Gather portion of the crumbled soil and put it into a moisture can. Get the moisture can with the soil sample and immediately measure its weight. Weigh the moisture can with soil and leave it in the drying oven for at least 16 hours.
Tomorrow.
After at least 16 hours, get the moisture can with soil and immediately weigh it.
Here are the data, computations, and graph calculated during the group experiment last February 18 to 20, 2016. From the data and computations, we can conclude that the soil from Antipolo Rizal has a liquid limit of 42.857 and a plastic limit of 42.222. The plasticity index was also computed to be 0.41. The group also concluded that the soil begins to stiffen when the water content decreases.